Welcome to the 2021 WoodWorks Wood Design Awards. WoodWorks' annual Wood Design Awards program celebrates excellence in wood design and construction across the U.S. and the teams that make the projects a reality. In a rapidly changing world, innovation and progress go hand in hand. Year after year, developers and design teams push the envelope on wood design to create solutions that meet the needs of modern life. This year's winners showcase wood's beauty, sustainability, resilience, and versatility, serving as an inspiration for those who follow in their footsteps and for the people who live, work, and play in the spaces themselves. As always, we'd like to thank the organizations that support WoodWorks, enabling us to provide technical assistance, education, and resources to design and building professionals across the U.S. A special thanks goes to our funding partners, the Softwood Lumber Board, USDA Forest Service, and Forestry Innovation Investment. We'd also like to acknowledge our 2021 board partners, including Boise Cascade, Georgia Pacific, LP, West Fraser, and Weyerhaeuser, and this year's independent jury, who committed their time and selected 19 exceptional projects from an outstanding pool of nominations. Claire Archer, Vice President Senior Director, Gilbane Building Company, Washington, D.C. Kate Diamond, Civic Design Director, HDR, Los Angeles, California. Julie Hiramoto, Well AP, Director of Integration, Principal, HKS Incorporated, Dallas, Texas. John Mitchell, Associate Partner, Hartshorn Plunkard Architecture, Chicago, Illinois. And now, meet the winners of the 2021 Wood Design Awards. Designed by Engberg Anderson Architects, Timber Lofts blends old with new, melding the renovation of an historically significant 1891 industrial loft building in Milwaukee's Walker Point neighborhood with the construction of a sleek new 4-story addition. The addition punches into the existing brick building at each floor, creating a continuous interior loop that showcases exposed wood framing in both structures. Luxury apartments in the new building blend high style with an eco-friendly warm aesthetic that features exposed glulam columns and beams and CLT ceilings, all highlighted by stunning floor-to-ceiling windows. Timber Lofts was certified as an historic structure by the National Park Service and utilized historic tax credits, which meant that all aspects of the 60-unit project had to be reviewed and approved by the NPS. Timber Lofts was also the first building in Milwaukee to be constructed using CLT. Two buildings comprise Oregon State University's new Forest Science Complex, designed by Michael Green Architecture. PV Hall, which houses classrooms, laboratories, and informal learning spaces, was built using unique CLT rocking shear walls, designed to self-center during a seismic event, along with CLT floor panels supported by glulam columns and beams. Sensors installed throughout the building gather moisture and structural movement data, which will be used for ongoing research into mass timber structural performance. An atrium, located at the heart of PV Hall, features towering glulam columns topped by mass plywood panels, marking the first commercial use of this innovative wood product. This unique framing system is designed to meet both high seismic requirements and the long spans needed for the sizable space. The AA Red Emerson Advanced Wood Products Laboratory provides space for wood products manufacturing and structural testing. When Cakebread Cellars expanded their renowned Napa Valley winery, they chose a stunning wood-centric design to celebrate its rich history, adding a new visitor center with 9 new tasting rooms, office space, and a new production area. The BCV Architecture and Interiors design team made innovative use of heavy timber and light wood framing in their new hospitality and production areas, creating a modern tasting experience for guests and seamlessly integrating the new facilities with existing buildings on the property. Glulam beams frame the grand entry, setting the stage with a stunning yet serene atmosphere. Inside, custom wood light fixtures provide a natural, dramatic focal point, highlighting the wood walls and ceiling. Wood also features prominently in the tasting rooms, creating an atmosphere that is both sophisticated and welcoming. Finally, glulam beams and wood decking frame the expansive production area, so the view into the work area matches the rest of the winery's luxe aesthetic. Skylab designed Outpost to function as one large structure, with each of its 2 3-story buildings aligned within the exterior envelope, but separated to create a central, shared area with terraces, outdoor fireplace, and expansive pavilion. Locally sourced glulam beams are left exposed throughout, complemented with infill walls and pathways covered in Douglas fir decking. Outside, both buildings feature naturally finished cedar on the ground floor and charred cedar cladding above. The visual distinction between upper and lower floors reveals the unique functional separation inside the building. Outpost's ground floor houses light industrial activities, including a brewery, distillery, and maker spaces, while the upper floors offer retail, office, and recreation spaces. Moving traditional street-level retail to the second floor means that shoppers and restaurant-goers have views of the Columbia River, Mount Adams, and Mount Hood, while first-floor industrial tenants enjoy street access and double-height spaces. A simple, light, wood-frame design by Digsaw provided an economic building solution for the Discovery Center, an urban bird sanctuary and leadership development center. 2 wings of the building, each with platform-framed walls and prefabricated roof trusses, are joined by a connecting roof. The east wing includes exhibition space, meeting rooms, administrative space, and a storage area, while the west wing includes a large multifunctional event space for meetings, workshops, and gatherings. Plated wood roof trusses have been left exposed in all primary interior spaces, and the building is flanked by a nearly 500-foot-long charred cedar facade and site wall that incorporates bird nesting shelves. The light-colored cedar-clad entry portal welcomes visitors, while the dark charred cedar creates a neutral backdrop to the seasonal colors of the landscape. In keeping with the center's community focus, exterior wall panels were flame-charred, shop-fabricated, and installed by a nonprofit construction training program that introduces urban youth to the carpentry trades. A 2014 earthquake left the historic Trefethen Winery in a precarious tilt when the second and third stories shifted nearly 4 feet. Because it was built in 1886 and listed on the National Register of Historic Places, the Trefethen family decided to undertake an extensive restoration. Crews removed and repaired the exterior redwood siding, then strengthened and straightened the internal wood structure by adding 2 bolted connection steel moment frames, aligned with the original timber posts. The team was able to preserve the majestic vaulted spaces in the tasting room and barrel storage area, while still showcasing the original timber construction. Next, they installed new exterior shear walls and reclad the building using the original redwood siding. As a final tribute, the Trefethen family left a single remembrance post in its deflected state to illustrate the magnitude of the earthquake withstood by the structure. Innovative is a key descriptor for the Kendeda Building for Innovative Sustainable Design, which is the first timber structure built at Georgia Tech since the 1880s. The building houses lab space, classrooms, and a lecture hall, all surrounding a 2-level atrium. The design team, which included the Miller-Hull Partnership in collaboration with Lord X Sargent, puts wood on full display using an array of building materials, including nail-laminated timber decking, glue-lam beams and columns, and salvaged wood for stair treads. Hybrid glue-lam and steel queen post trusses span the large spaces. Gravity and lateral elements are left exposed to give students a visual register of the structural forces at work. Exterior wood siding was harvested from recovered cypress sinker logs, and a steel porch canopy captures enough rainwater and solar energy to meet the site's water and energy demands. The highly sustainable project is pursuing Living Building Challenge certification. Designed by Centerbrook Architects and Planners, Duke University's new Alumni and Visitors Center is the first structure people see as they arrive on campus. Administrators wanted a design that aligns with Duke's identity as the university in the forest and signifies their commitment to sustainability and environmental stewardship. The four-building complex includes an event center with a large lobby, meeting pavilion, the historic Four Lines House, and a new office building for the Alumni Association. Wood was used inside and out as both structure and finish to enhance the connection between the built and natural environment. The two public buildings feature vaulted ceilings formed by complex southern pine glulam arches, which allow space for clear-story daylighting. Wood ceiling panels are spaced for acoustic control. Floors are red oak, and the wood paneling, desks, and cabinetry are made from white oak harvested from Duke's own forests. The arcade was built using cypress glulam, selected for durability and constructed to match the soaring glulam arches inside. Surrounded by land reclaimed from a demolished concrete parking lot, the 330-foot-long Jones Beach Energy and Nature Center houses offices and classrooms, while a continuous exhibition space flows from gallery to gallery, spilling out onto a shaded canopy and amphitheater. N Architects designed the silhouette of the mass timber roof structure, framed with glulam beams and wood decking, to evoke a series of waves that reflect the center's mission of environmental education. Timber piles form a pier-like deck surrounding the center, addressing the constraints of the building's location on a floodplain and connecting it to the coastal context. The natural patina of the cedar cladding will fade to silver, blending with its natural setting. Inside, the warmth of wood welcomes visitors, creating a comfortable atmosphere that promotes learning. The Net Zero building generates as much energy as it consumes from its 260 rooftop solar panels. The Freedom House expansion project demonstrates how wood can be used to create simple, affordable, yet beautiful housing. Freedom House Ministries needed a new facility to support residential needs for transitional housing and spaces for administrative staff and programming services. A challenging site prompted the design team at Berners Schober to develop a bifurcated plan, separating the two occupancies but linking them with a glazed bridge. The structure with 5 gabled roof forms provides space to house up to 16 families, each in private rooms with dedicated bathrooms. The larger administrative wing, where programming spaces are located, is built into the adjacent hillside. Light wood framing was used for all primary structural elements, including walls, roof, and floors. Use of natural cedar cladding unifies the two buildings and speaks to the goal of providing simple, sustainable living with a familiar, warm, and welcoming aesthetic. Wood's ready availability fit the tight construction timeline, allowing the shelter to open before winter arrived. Located in a neighborhood filled with decades-old timber lofts and former meatpacking warehouses, 1040 West Fulton expanded the area's rich heritage when it became one of the first multi-story timber office buildings to be constructed in Chicago in decades. Heavy timber was an obvious choice for the Hartshorn-Plunkett architecture design team, since exposed wood spaces were sought after by tenants seeking leases in the historic district. At the time this project was built, the Chicago Building Code allowed a prescriptive path for mass timber construction, but did not specifically recognize glulam. The team worked closely with building officials, and the city chose to update its building code to provide new allowances for glulam construction. 1040 West Fulton's structure is a mix of steel, concrete, and heavy timber with exterior walls comprised of steel columns and beams that support the brick cladding. The interior structure includes glulam columns, girders, and beams with tongue and groove wood decking, left exposed to differentiate the iconic address. Johnson Markley designed the new UCLA Margo Leavin Graduate Art Studios, which involved the renovation of a former wallpaper factory to expand studio space for the university's Master of Fine Arts program. To retain the open industrial spirit of the existing building, the original warehouse was renovated and a new L-shaped addition built around it, adding artist studios, lab spaces, a gallery, classrooms, and covered outdoor space. After restoring the wood bowstring trusses in the original warehouse, the team used concrete tilt-up walls and a curved wood vault roof for the new structure. Glulam was chosen to extend the character of the original wood trusses, and the unique vaulted configuration was adapted to reduce double curvature while maintaining large, clear spans. High ceilings, expansive spaces, and natural light support the creative endeavors within the LEED Gold certified studios, which include ceramics, painting and drawing, photography, sculpture, and more. By using CLT for the roof and walls of this tennis pavilion, the design team at Generator Studio incorporated an unexpected but aesthetically warm and structurally progressive building solution. The pavilion, located in the heart of an historic athletic club, anchors the otherwise unstructured tennis court layout. Clean lines of the sloped CLT roof extend seamlessly from inside out, inviting natural light in while forming shaded platforms outside that connect viewers to players in the courts. The scissoring roof form reduces the building's energy use by minimizing thermal breaks and allowing for improved insulation and natural ventilation. Inviting aesthetics of the wood panels provide material warmth for the pavilion, which houses a pro shop, gathering areas, indoor and outdoor seating, food and beverage area, and locker rooms. Large panel sizes and a slender roof profile create a contemporary interpretation of the existing clubhouse veranda, while use of natural wood stays consistent with the progressive and environmentally conscious nature of the club. This small but beautiful structure designed by the Living and NK architects stands out for its detailing and use of sustainable materials, serving to inspire those who use it for architectural research. The facility is used for interdisciplinary educational collaboration on fabrication, robotics and sensors, studies where computers meet the physical world to become embodied computation. With glazed doors that fully open at one end, the large double-height warehouse-like building allows for flexible reconfiguration of classroom, workshop, testing, and research space. Since low carbon emissions is a key focus for the work that goes on within, wood was a natural choice. Inside, a 5-ton gantry crane rides along rails sitting atop the glulam post and beam structure. Scaffolding boards salvaged from New York City construction sites were sandblasted and then used as exterior cladding, giving the building a uniquely beautiful, weathered facade. This unique office building, the first in Denver to use CLT, features a highly efficient floor plan, floor-to-ceiling windows, and a rooftop deck. The Design by Oz architecture provides unobstructed views of downtown Denver and the Rocky Mountains. Glulam beams and columns and CLT floor and roof panels are left exposed, visible from both outside and in, to create an iconic business address for this spec office building. A desire to use sustainable building materials drove the decision to use wood, and the design team created an elegant interior to take full advantage of the exposed structure. They carefully coordinated MEP locations to preserve the clean look and feel of the wood, which also increased construction efficiency. Because this was Denver's first CLT building project, the design and construction team gave area students, building officials, fire departments, and surety partners tours and opportunities to learn about the material, smoothing the way for future mass timber projects. Designed by Weber Thompson, Cedar Speedster pays homage to the neighborhood's wood-centric history with heavy timber construction, exposed wood car deck ceilings, and exterior cedar cladding. Housing the offices of a leading outdoor retailer, the exposed wood structure reflects the company's commitment to authentic outdoor lifestyle and experiences. 2 restaurants and a brewery tap room occupy the ground floor of the expressive wood structure, and the cedar-clad exterior is accented by weathering steel. Innovative connection details highlight the interaction between the wood structure and other materials. Glulam columns run continuously from the ground floor to the roof to reduce shrinkage and speed construction. The Douglas fir decking was installed unfinished, allowing the natural wood to create an environment designed to boost employee well-being and productivity. Wood is not a typical building material choice for industrial structures, making the attractiveness of the biomass boiler building even more noteworthy. This small, 33-foot wide single-span facility, designed by AML-GM, houses a community-scale biomass boiler with a small-scale power generator. The innovative system uses organic waste material to generate heat and power for the adjacent Plumas County Health and Human Services Department. Plumas County had originally envisioned a traditional prefabricated metal building, but turned to wood to underscore their commitment to renewable materials and sustainable forestry. The CLT roof and wall panels act as both vertical and lateral force-resisting systems, making this the first application of CLT shear walls in California. The county's decision to use a mass timber system also provided benefits in terms of speedy installation and small crew size requirements. From concept development to substantial completion, the project was completed in less than a year. Wood and steel worked together in the design of this lakefront recreation complex for Clemson University students. Designed by Cooper Carey, the center features social space, rooms for activities such as yoga, rowing, and aerobics, and traditional classrooms. As Clemson's first mass timber facility, the center features CLT floors, roof, and shear walls, supported by glulam beams and steel columns. The southern yellow pine CLT panels were manufactured in nearby Dothan. Designers left the structural wood members exposed, eliminating the need for almost all ceiling finishes, which helped reduce construction material and labor costs. The expansive roof's large overhangs provide shade for terraces where students can relax outside. Visual warmth of the exposed wood speaks to the function of the facility, emphasizing its role in promoting fitness and wellness for Clemson students. This project is a beautiful example of how sculptural wood can be used to distinguish a modern addition to a traditional design. Designed by H.H. Architects, the expansion of this prominent Dallas church consisted of a new parish hall, a new 300-seat chapel, and a prayer room. The Gothic-style chapel and 3-story parish hall Both feature heavy yet intricate wood roof trusses, designed to create a visually inspiring focal point in each. The chapel features a glue-lam hammer beam truss ceiling that soars over the worship space. Glue-lam beams over the parish hall are similar in size and shape, arched to frame the beautiful windows. The glue-lam trusses have concealed bolted connections, leaving visual focus on the wood itself. Tongue and groove wood decking and wood purlins span the glue-lam trusses in both spaces, leaving a warm yet elegant view above. WoodWorks is honored to celebrate the winners of the 2021 Wood Design Awards. Winning projects will be featured in the book Celebrating Excellence in Wood Architecture, a collection of 2020-2021 North American Wood Design Award winners. We hope these projects offer inspiration and excitement about the possibilities of wood design. For more information about these projects and the teams behind them, visit the online gallery at woodworks.org. Congratulations to all the 2021 WoodWorks Wood Design Awards winners.